right, guys, now that we have looked at our absolute value graphs and their attributes, let's look at them, how we're going to actually graph them on our coordinate plane. So this f of x equals the absolute value of x. This is what we call our parent function. So we have parent functions for every single one of our functions that we graph. It's basically just saying that this is the basic graph and nothing is happening to it. So let's go ahead and graph this parent function by plotting points. That's how we generally graph. And because I know what the absolute value graph looks like, we are going to start at -2. So when I plug in, remember, in order to find this, we need to plug it into our function. So the absolute value of -2, remember the absolute value, when I put in a negative number, it pops out a positive number. So that's +2. So -1, pop. This board hates me. All right, -1 pops out a +1, maybe, yeah. 0, 0, 1, 1, 2, 2. So let's plot these points. We got -2, 1, 2. I think I put that on the wrong line. That should be 2 right there. -1, 1, 0, 0, 1, 1. This graph is weird. 1, 2, 2. Okay, these are my parent function points. Connect my points. My line is terrible. But this is what the parent function of our absolute value graph looks like. So what we're going to do in order to graph our other absolute values is we're going to use this, and we're going to look at what is happening to it in terms of transformations. So we'll review transformations in just a second, and then how it relates to absolute value. But you're going to continue to plot these 1, 2, 3, 4, 5 points on all of our graphs in order to graph the other absolute value. So transformations, if we remember, we've got a couple here: translations, stretch and compress, which is our dilation, and then our reflection. So our translation is how we're moving it. If we're moving it left and right and up and down. And then our stretch and compress, I don't know whether we're making it wider or more narrow. Come back. And then our reflection, remember, that is like when we reflect it over an axis or a line. Okay, so we've done multiple things with our transformations in the past, and now we're going to do it with our absolute value. So instead of giving you an absolute value function and then having you plot a bunch of points, because of how absolute value works, then this is the easiest way to graph absolute value. Is you take your parent function points and then you move them however the function is telling you to based on the transformations. So, excuse me. The part that is telling us to move left or right is my inside number of h. So this is left to right. And this is the one that is closest to your x. Okay, remember when you're inside by your x always lies. What do I mean by that? So the inside h closest to your x lies. So you go the opposite way than you would think. So if it is a negative, you would think you would go left, but you're going to go right. So then the opposite is true. If it is a positive number inside, then you're going to go left. Okay? Inside, by the x, lies. Go the opposite way. My k on this outside tells me whether I'm going up or down. This one, let's see, up. Really? There we go. Up or down is outside. Okay. This one tells the truth. So if it is positive, you're going up. And if it is negative, you're going down. Okay. Our stretch and compress. Come on. Yeah. Where is my... I went the wrong way. Where is my pens? My colors? The stretch and compress, you're looking at the A on the outside, or the number on the outside of your absolute value that's being multiplied by your absolute value. Excuse me. So you're looking at your A. So this one, if the absolute value of A is greater than 1, then you gotta stretch by that number, and it is narrower. And then the opposite is true. If the absolute value of A is less than 1, meaning it's some kind of fraction, and it's going to be compressed by that number, and it's going to be wider. Okay? Finally, our reflection, we're going to look at the sign in front of A. So, sign in front of A. And if it is a positive number, it opens up. And if it's a negative number, it opens down, which means that it is reflective. Because opening up with the positive is our parent function. All right, check back for the examples on your notes.